All right, everybody have this copied down? Yes. Okay, so today we're looking at 10.3. 10.3 is called composition and inverse functions. Sure. So first thing we need to talk about is function notation. So function notation is basically when you have an f, and then in parentheses next to it you have an x. You guys have probably all seen it. It simply means the same thing as when you see y. Okay? And when you go to read it, you say f of x. I just call it fancy. It's fancy notation. So as soon as I see the f, I think fancy notation. And so in my head, I just go, oh, that fancy notation, it's really just y. All right? So we talked about this a little bit last semester, and we did something called compositions. And it's where you take two of them and stick it together. So if you have something like this, you read it as f of g of x. So you have one inside of the other. You guys sort of remember that? Okay. Who remembers the little trick? Nobody. Okay. So if you're given, when you do these kind of things, you're going to be given some information. You're going to be given two functions, like one being f of x is x squared, and one being g of x is equal to 2x. And then they'll say, what is the f of g of 3? The f of g of 3. So the trick is that you want to work from the inside out. Inside out. So you want to start with the innermost function. So in this one, you're going to start with the g. And you're going to plug in the number that they give you. Wherever you see x. On both of these two functions, they only give you 1x. But they could give you x squared plus 3x plus 7. And you'd have to plug it in twice, right? Or they could give you x cubed plus 2x squared plus 7x, blah, 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 whatever. How many ever times you see x is how many times you plug it in. So we're going to start with the g of 3 first, because that's the innermost function. We're going to plug, bless you, we're going to plug that 3 in and get a number. Whatever number we get, we're then going to take that number and plug it into the outside function, the f. So it's really like it's the second answer is your final answer. All right, so let's take the 3 and plug it into the 2x, which is 2 times 3. Super easy, you should get 6, right? Now you're going to take that 6 and you're going to plug it into the f. So this time we'll say f of 6 is equal, and this function is to square it. So we're going to take the 6 and we're going to square it. We get 36. So the final answer, the f of g of 3, having done both, is 36. Bless you. Let's try one that's just slightly harder. Any questions on example number 1? All right. So you're going to be given two functions. First one is f of x equals 3x minus 5. And the second one is g of x equals the square root of x. And we're actually going to do this one twice. So for little letter a, we're going to do the f of g of 4. So which one do I plug the 4 into first? The g. So we're going to do g of 4, which means we're going to have the square root of 4, which is 2. Now we're going to take that answer and plug it into the outside function x. So we're going to do f of 2. So we're going to have 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. We're going to use those same two functions, but this time, instead of doing f of g of 4, we're going to do g of f of 4. So this time I plug it into which one first? F. So we're going to do f of 4, and f is the 3 times 4 minus 5. We simplify that, we get 3 times 4 is 12. 12 minus 5 is 7. Now we take that number and plug it into the outside function g. So we're going to have the g of 7. And we get the square root of 7, which is going to give us a what kind of answer? Decimal. So either leave it as a radical. If it's a perfect square, simplify it. If they tell you to write it as a simplified radical, see if it has any perfect square factors, that kind of thing. But otherwise, you're done, right? Any questions on A or B there? All right, let's look at, well, those two were compositions. So now let's look at an inverse function, all right? Anybody still copying example 2 down? All right. So now we're switching to inverse functions. And to know the difference, you're going to see a little -1 exponent. That's just the inverse function. Okay? So for example, number 3, you're going to start with a function. And let's say you're given x cubed minus 3. Remember at the beginning of the lesson when I said, oh, when you see this fancy notation.
Minus 3, then you wrote it.
Oh, I meant x cubed minus 1. Sorry. Because I was looking at the 3. Sorry. It's x cubed minus 1. All right. So at the beginning when I said this fancy notation really just means what? Y. So we're going to rewrite this as y equals x cubed minus 1. And then, because we're asked to do the inverse function, we're going to switch our x and our y. So right here where we see where we see y, we're going to write x. And right here where we see x, we're going to write y, so y cubed minus 1. And then we're going to do inverse operations until we get that y by itself. So 2 operations are happening to this y. It's being cubed and 1's being subtracted, right? So first thing we want to do is add 1 to both sides. So we get x plus 1 equals y cubed. And then the inverse operation of cubing is what? Cube root. So we're going to take the cube root of this side, and we're going to take the cube root of this side. Okay? These are inverse operations, so they essentially cancel each other out, and we're left with y. And then over here we have the cube root of x plus 1. So that's what we call the inverse operation. So now we're going to switch this y back to our fancy notation. So we say the inverse function of x is equal to the cube root of x plus 1. And that's how you'd write your final answer, just with that fancy notation. All right, so the last thing you're going to be asked to do is to graph some inverse functions. Okay, so if you see an equation like y equals 2x minus 4, if you were to graph that, what would that look like? The y-intercept would be negative 4. What else? Slope is 2 over 1. So this is a what? It's a line, right? So you're going to see not just y equals 2x minus 4. The way they're actually going to give it to you is they're going to have f of x equals 2x minus 4. And so what happens is sometimes when people see this fancy notation, they all of a sudden don't know what it is. But this is the same thing as this. Okay? So when you see this, the first thing you should do is write y equals 2x minus 4. Just change that fancy notation, simplify it down to y equals 2x minus 4. Then you're going to switch the x and the y. So this becomes x, the y becomes x, and then the x becomes y. And then you're going to solve for the y again. Just do your inverse operations. So add 4 to both sides, and you get, bless you, x plus 4 equals 2y. And then the y is being multiplied by 2, so divide everything by 2. So you get 1/2 x plus 2 equals y. And then change it to your fancy notation. And so you're going to get f of, or the inverse function of x is equal to 1/2 x plus 2. So what you'll do at that point is you'll go to Desmos.com. You're going to graph the original equation, so the y equals 2x minus 4, and then you'll graph the inverse one. You can either, well, I would leave it in this form, y equals 1/2 x plus 2, and you're going to see what happens. And we'll check it out in just a second. So then what you're going to do is you're going to sketch it on your in your assignment. Okay. Yes, sir.
I just have a question about the composition functions. So when we did the g of 4